2 billion people. Over 100 billion messages sent every single day. For most of its life, this entire platform ran on a backend team you could count on two hands. So how does an app that small move messages that fast, that reliably, to that many people? WhatsApp today is voice calls, video calls, group chats with hundreds of people, payments, business accounts, disappearing media, all running across every phone, every carrier, every corner of the planet, including places where the connection is 1 bar or 2G. The infrastructure has to assume the network is bad and build around that instead of hoping for the best. That single assumption shapes almost every decision underneath the hood. So what happens the second you hit send? Your message doesn't go phone to phone directly. It goes to WhatsApp servers first, gets matched to the recipient's connection, and gets pushed down to their device. A round trip that has to happen in a fraction of a second at a volume most systems never touch. The original architecture learned on Erlang, a programming language built decades ago for telecom switches that hold millions of connections open at once without falling over. A messaging app and a phone switchboard are solving the same core problem: keep an enormous amount of persistent connections alive and move small packets between them instantly. Each phone keeps an open connection to a WhatsApp server. Multiply that by 2 billion users, and the system spends most of its time routing rather than storing. If you're online, your message gets handed off immediately. If you're offline, it sits in a queue waiting for your phone to reconnect, then gets delivered the moment it does. That's the single check mark turning into two. Encryption is where WhatsApp does something most messaging platforms still don't. Every message is protected by end-to-end encryption using the Signal protocol, scrambled on your phone before it ever leaves, and unscrambled only by the recipient's phone. WhatsApp's own servers can't read it, and neither can anyone sitting in the middle. Each conversation runs on its own set of constantly rotating keys, so exposing one key doesn't unlock an entire message history. 100 billion messages move through the system every day, and nobody in the middle reads a single one. Group chats push the difficulty further. A one-on-one message is a single delivery problem. A group of 200 people is 200 delivery problems happening at once, each with its own connection status, its own device, its own encryption key. Every member's phone independently encrypts and decrypts the same message using its own session with every other member. The server's only job is to fan that message out to everyone in the group as fast as possible without ever seeing the plain text. A large group feels instant, but structurally, it's running dozens of parallel handoffs behind one message bubble. Media adds another layer entirely. Photos, videos, and voice notes don't travel through the same small pipe as a text message. Media gets uploaded once to WhatsApp servers encrypted, and the recipient's phone is handed a link and a key to fetch and decrypt it on its own. The messaging layer stays lightweight and fast, while the media layer absorbs the heavy lifting separately. Multi-device used to be the real architectural headache. For years, WhatsApp only worked if your phone stayed connected, because your phone was the source of the truth. Your laptop was just mirroring it in real time. WhatsApp eventually rebuilt this, so each device holds its own independent encryption identity, syncing message history securely across devices without needing your phone turned on nearby. Underneath that convenience, every device you own becomes its own endpoint in the encryption chain, multiplying the complexity of every message by however many devices you're logged into. Now for presence. Your last seen, the typing indicator, the blue check, all of this rides on a constant quiet stream of tiny status updates in the background. Using the same always-on connection, your phone already keeps open for messages. And here's the part that still stands out. For most of its early growth, WhatsApp scaled to hundreds of millions of users on a strikingly small engineering team. Erlang's design let a single server handle an enormous amount of simultaneous connections without an army of engineers babysitting it. Since joining a larger infrastructure, WhatsApp has layered in far more scale underneath, but the early philosophy stuck. Keep the core lean, let the language and architecture absorb the load, and only add complexity where the problem genuinely demands it. None of this comes down to one clever trick. Connection handling, encryption, media, groups, and multi-device sync were all built as separate problems solved independently, and stitched together tightly enough that you never notice the seams. 100 billion messages a day, every one locked before it leaves your hand. All of it running so quietly, you never think about any of it until now.